Atomic structure in the periodic table. Part 1, basic atomic structure. Atoms contain protons, which are positive, neutrons, which are neutral in their nucleus, and negative electrons orbit them in shells. Protons and neutrons have a relative atomic mass of 1, and electrons are approximately 2,000 times smaller. Atoms contain an equal number of electrons and protons, which gives an overall neutral charge on the atom. Mass number is the number of protons and neutrons, as the electron's mass is so negligible compared to them. Atoms with differing mass but the same atomic number are called isotopes. The example here worked through is chlorine. Chlorine has a 35 isotope and a 37 isotope, so 2 neutron difference. To work out the average mass of chlorine, you do this. The average abundance of the 35 isotope is 75%, 37 isotope is 25%, so you times their masses by their abundance, get a number, and then you divide it by 100 as you've used the percentage to get the average 35.5. Part 2 of the periodic table. Elements are placed in groups with similar chemical and physical properties. As you go down the group, size increases as more protons, electrons and neutrons are added. Metals are left and centre, and non-metals are on the right of the periodic table. As you move across, so you go across a period, 1 is added to the electron configuration as you add a proton and an electron, balance the charge. So the electronic structure is as follows. Hydrogen 1, as there's only 1 electron orbiting, 1 proton in the nucleus. Helium 2, as you have the 2 on the outside. Lithium 2, 1. Beryllium 2, 2. Boron 2, 3. And as shown below. Example of a reaction here. Sodium solid, chlorine gas react to form sodium and chloride. Sodium is positive charge, chlorides have a negative charge. They attract each other and they form an ionic bond, which is very strong. Table salt, NaCl. Group 1, the alkali metals. As you descend the alkali metal group, the outermost electron is further from the positive nucleus. So the outermost electron is also known as the valence electron, and that's the one in chemistry we're most interested about, because that's the one that will be swapped, or the shell that will gain an electron in a reaction. So the positive nucleus is pulling on these electrons, so as you go down the group and the furthermost electron gets shielded by inner electrons and further away from the nucleus, the reactivity increases because it's easier to take that electron away. When reacted with air or oxygen, alkali metals form their oxides. There's an example here, 4Na plus O2 goes to 2Na2O. There's some flame tests for the metals, the alkali metals, and the alkali earth metals. Lithium gives a red flame, sodium gives an orange flame, potassium gives a lilac purple flame, calcium gives an orange red flame, and beryllium gives a light green flame. When metals react with water, they release hydrogen gas. The test for hydrogen gas is by placing a flame, a lit splint or a flame over the area, and if the flame pops, hydrogen gas is present. The reaction shown below, potassium plus water is potassium hydroxide plus hydrogen gas. Halogens. Halogens are less reactive as you descend the group. This is because they want to accept an electron, as they want to get their octet. If they want to gain 1 electron to get their full outer shell. So as they go further down the group, they're further away from the pull of that nucleus, and they're less reactive. When halogens react with water, they form their acid and what's known as a hypoacid. And here's the reaction here: chlorine plus water with hydrochloric acid and hypochloric acid. This is used a lot in bleaches and stuff. The hydrogen's usually lost, and then it's the OCl minus that actually does the bleaching in most bleaches. Silver nitrate test can be used to actually decipher what halogen you have. So if there's fluoride, F minus, with no precipitate when you react with silver nitrate. chloride, we have a white precipitate. Bromide, you have a cream precipitate. And iodide, you have a light yellow precipitate. When displacement reaction is used on halogens, the more reactive halogen replaces the least reactive. So in this example, potassium iodide is reacted with chlorine, and it forms potassium chloride plus iodine. So if it was the other way around, the chlorine wouldn't be, the iodine wouldn't be able to replace the chlorine. But if that was iodine, if the iodine was the other side and the bromine was there, it couldn't. Do you know what I mean? It's got to be below it. Chlorine is used in bleach, plastics, polyvinyl chloride, solvents, dichloromethane, and in a lot of dyes. Iodine is used in ink, disinfectants, like over-the-counter disinfectants as well, and in iodine supplements. Noble gases. Noble gases are unreactive in most circumstances. This is due to their complete outer shell. The valence shell is full. They either have 2 or 8 in their outer shell. They don't want to lose one, don't want to gain one. It's thermodynamically unfeasible for them to, it'll cost more energy for them to lose an electron or gain an electron than it is for them just to be what they are and just float about. This doesn't make them useless, though. There are many uses. Due to their unreactivity, also it helps. For example, in argon, they're used to protect light filaments from oxidation. They're also used as an insulating layer in some glasses. You can get argon-filled glass. It's a very good insulator and works really well. Neon is used in lasers and high-power lights. And helium is used in balloons, fill up balloons, in arc welding, and as a pressurizing agent for rocket fuel. So I've got some worked examples now, if you want to go through it and leave it or whatever, but I'm going to go through it now. If you want to pause or leave it, but I'm going to go through it. So atoms contain particles called electrons, protons, and neutrons. Diagram below shows an atom of boron. From the above diagram, fill in the blanks below. So the nucleus of boron atom contains 5 and 6 and 5 in the shells around the nucleus. So it contains 5 and then 5 in the shells around the nucleus. So what have we shown? We've shown that it needs to be protons and electrons are balanced. So it'll be 5 protons, 6 neutrons, and 5 electrons. And the particles in the atom which have the positive charge are called, and because they've got a balance, the protons. Quick second example here to work through. Group of metals react with oxygen to form metal oxides. Sodium oxide contains the 2 ions, Na+ and O2-. Select the correct formula of sodium oxide. So what is needed to balance that charge? The answer is C, Na2O, because you have 2 minuses and 1 plus. So 2 sodiums come and bind to the 1 oxygen, and that balances out the charge, and is neutral and balanced.